Namaskar and a very good afternoon to everyone. My name is Professor Dr. Mayur Dongre and I am a professor at Botany Department, Shri Shivaji Vidya Prasarak Sanstha's Letkar Mayur Para Dongre Mahavidyalaya, Dure, Maharashtra, India. Today I am thrilled to speak at this vital conference on interdisciplinary research for a sustainable future. We will be diving into a topic that sits at the intersection of mycology, agriculture, and technology. My topic is climate change and pathogen shift, predictive modeling of fungal disease outbreak in Maharashtra onion crop. The challenges before us is immense, but it is an opportunity for innovation. Every challenge is a origin of innovation. Over the next few minutes, we will explore the critical role of onion cultivation in our state, identify the key fungal diseases that threaten it, and understand how climate change is dangerously amplifying this threat. Most importantly, we will discuss a forward-looking solution using predictive modeling to move from reactive to proactive and sustainable management strategy. First, let's see the stages. Why onion? And here in Maharashtra, why Maharashtra? The onion isn't just a vegetable, it's the backbone of our horticulture economy. Our state proudly produces nearly 40% of Indian total onion crop. For millions of farmers, especially in the region of Nashik, Pune, Jalgaon, Dhule, it is their lifeline. The stability of this crop is directly tied to the economical stability of rural communities. But this lifeline is under constant attack from invisible adversaries. I'm talking about fungal pathogens here because I am pathologist. Here are the three main culprits we face season after season. Purple blotch caused by Alternaria pori, leaf spot caused by Cercospora dudi, and stem phylum blight by stem phylum Fascicarium. This fungi can decimate a crop in matter of weeks, turning a field of green promises into a story of loss. For decades, farmers have fought these diseases, but now the battlefield itself is changing. Climate change is no longer a future threat, it's a present reality, and we face it. Warmer average temperature allow these fungi to complete their life cycle faster, meaning more generations and more infectious in a single season. Erratic, heavy rainfall, which are seen more frequently, creates a splash effect that spreads spores like wildfire and stresses the plants. And finally, prolonged period of high humidity create the perfect moisture environment on the leaf surface for this fungal spore to germinate and invades. In plant pathology, we have a fundamental concept called disease triangle. For disease to occur, you need three things in balance: a sustainable host, like our onion plant, a virulent pathogen, like fungi we saw just, and the favorable environment. When these three align, disease is the inevitable outcome. What climate change does, it is dramatically tilt this triangle. It supercharges the environment side of the equation. As you can see, by making the environment more favorable for the fungus, the area of disease expands exponentially. The delicate balance is broken, and our farmers face epidemics of a scale they have never seen before. Our traditional approach has been reactive. We see the disease and we spray fungicides. But In this new climate reality, this is often too little, too late. It's inefficient, costly, and has significant environmental consequences. To build a sustainable future, we must change our strategy. We need to move from treating disease to predictive risk. And this is where predictive modeling comes in. The concept is simple and powerful. We use data about the environment to forecast the probability of a disease outbreak before it happens. We take weather data, feed it into an intelligent model like AI and machine learning, and that model provide an actionable forecast alerting the farmers that conditions are becoming dangerous like SMS, call, etc. So, what does this model feed on? Data. We need real-time weather data from the field temperature, humidity, and rainfall. We combine this with historical data on past outbreaks and we enrich it with agronomic data like the crop's age and the variety. By integrating all this information, our model learns the specific environmental signature that precedes, for example, a purple blotch outbreak. This isn't just a theoretical idea. I am proposing a tangible case study right here in Maharashtra. We can begin by deploying low-cost sensor in onion field across Dhude and Nashik. We would collect data for a few seasons and use that data to train a machine learning model specifically for our local condition. The final output wouldn't be a complicated chart. It would be a simple alert sent to a farmer's mobile phone. High risk of purple blotch this week, time for preventing spray. Isn't it? It's very effective one. The impact of such system aligns perfectly with the goal of sustainability. It enables precision agriculture potential, reducing fungicide use by 30 to 40%. It saves the crop from devastating losses, which boost food security and protect farmers' income. And by reducing chemical use, we protect the health of our soil, water for future generation. But, and this is my most important point today, this is not a job for a plant pathologist alone. We are plant pathologists. We need support. To build this future, we need interdisciplinary synergy. We need data scientists to build the model, agriculture engineers to design and deploy the sensor, economists to assess the viability, and policymakers to help us scale it. True sustainability is built on collaboration. The challenges are significant, but our capacity for innovation is greater. By blending agricultural science with data technology, we can create a resilient and sustainable future for our onion farmers. Thank you very much for your attention. I would be happy to answer any question. You can mail me. Thank you.